Today we're going to talk about increasing, decreasing, and constant functions. So here we have the definition for what it means for a function to increase on an interval. So this is increasing on an interval. And it says that we can choose any two x's, an x1 and an x2, and as long as x1 is less than x2, f of x1 should be less than f of x2. So let's take a look at what this means graphically. I'm going to pick an x1 and an x2 such that x1 is less than x2. x1 is less than x2. And now I'm going to pick an f of x1 and an f of x2, except f of x1 has to be less than f of x2. So I'm going to put that here. And f of x1 must be less than f of x2. So those would line up here. If here's x1, here's f of x1, and here's x2, f of x2. And what you see is this point is higher than that point. So to get from here to here, our function would have to do something like that. And this is true no matter what x1s or x2s we choose. We're always going to have this increasing behavior where f of x2 will be greater than f of x1. Now let's take a look at decreasing. A function f is decreasing on an interval if for any x1 and x2, if x1 is less than x2, then f of x1 is greater than f of x2. So let's see what that means on our graph. Here's an x1, here's an x2, such that x1 is less. Now we're going to choose these y values such that f of x1 is greater than f of x2. So f of x1 has to be up here. Now I plot these points. x1 goes with f of x1, and x2 goes with f of x2. And notice, in order to get from here to here, that we have to move downward or decreasing. Okay, here's our third case. Our function may be constant on an interval if for any x1 and x2. So for this, it doesn't matter which one's larger. So for any x1 and x2, f of x1 is equal to f of x2. So we're going to pick an x1 and x2, and again, it really doesn't matter which is larger. And f of x1 must be equal to f of x2. So there we go. This would have to be horizontal so that we have these two equal function values. So here we have a nice little parabola, and we're going to talk about where this function is increasing, decreasing, and then constant. Now we're always going to read from left to right. So we start here, left, and then move to the right. Now what this function does is it decreases, decreases, decreases until it gets to this point here, turns around, and then begins increasing. So we need to state those intervals. And our intervals are going to be x values. We don't really care at the moment how high or how low this increases or decreases. We want to know for what x values the function is increasing and decreasing. So if we first look at increasing, our function begins increasing when x is equal to 1 and continues to do so forever. That goes on to infinity. So our function is increasing from 1 to infinity. Our function is decreasing way back here from negative infinity until x is equal to 1. So the function is decreasing from negative infinity to 1. And it's actually never constant. Here's another example. we're going to write down the intervals where this function is increasing, decreasing, or constant. Notice this one has a little bit more change. From left to right, we're increasing, decreasing, and then increasing again. So our first interval here, this is from negative infinity all the way up until x is equal to 0. We're increasing. So from negative infinity all the way up to 0, our function is increasing. Then when x equals 0, we start to decrease until x is equal to 2. So decreasing between 0 and 2. But then our function is increasing again from 2 until infinity. So increasing again from 2 to infinity, and once again, there is nowhere that our function is constant. Okay, we're going to do one more example, and let's say we're looking at a piecewise function, and let's make it a piecewise linear. And we'll say that this is -2 and maybe this is 4. So you can see here that this function is increasing, then constant, then decreasing. And again, when we write the intervals, we only refer to the x values. So our function is increasing all the way from negative infinity until x is equal to -2. So negative infinity to -2. Our function is constant between -2 and 4. And then finally, our graph decreases from 4 all the way to infinity.